When most people see a drone, they think props, battery, camera, done. Wrong. There's one board in the middle that keeps the entire thing from turning into a $1,500 lawn dart. How does that brain work? And what does it actually do?
And today we're going to go inside this and the builds and break down the main component of that flight control or of that aircraft, which is the flight controller. What it is, what is on it, the main firmware and options that you have for software to run it, and how to choose the right one for your mission, whether it's freestyle, mapping, or commercial ops.
Yeah, this is part one of our 7-part small UAS stack series. By the end of this series, you'll look at any drone and instantly know what's going on inside. Welcome to the Swarm News, where veterans and engineers talk about defensive tech the way it actually works. We don't do educated wishes here. I'm Joshua Hill and my co-host.
I'm Vincent Lewis, and appreciate Josh. I'll go over a little bit of news kind of before we get into the episode today. So, with some of the updated changes that are happening within the sUAS realm, recently, was it February 18th, the Army just did its first UAS or sUAS challenge with basically soldiers from the Army came together and did a competition in Huntsville, Alabama, where they went over different challenges in regards to something like your best sapper challenge or best ranger challenge, and going through different skills of what they could see as being one of the best things that, makes a drone operator it. So some of the things that they were doing were, one, building out an aircraft that actually it meets the needs and the actual soldiers actually building it themselves. One of the big things was they had a recon portion of it going over who could build one that was able to go out and find one hunter killer. So finding ways that who was the best one to be able to find out and killing the target they needed, and then just overall build competition, like who had the best aircraft that could be built out of this whole thing. That was a significant one for just looking at who and where the Army is going to for results in the sUAS realm of systems. So you had a name change in what you used to look at as, how your sUAS weren't even there. Now it's become a dominant point in the whole infrastructure of U.S. Army. And also there was another one. The Army is now incorporating for infantry schools. Now infantry and armor are having a part of the course guided towards sUAS and how to actually deal with them, know what they are, and handling them. I think that is a big one, especially, those who are infantry guys that you're normally not even having to worry about it, but because they consider these such a major threat to the combat landscape, they are now incorporating that into it. Also, the Pentagon's drone dominance program has been set to where they're saying that they're wanting to field more than 340,000 small sUAS by the end of 2027. That's a lot, but that's kind of in par with what China was at, where they're trying to get, like last year they put out a thing, they're wanting to build 1 million. Our company got 1 million orders for a specific or whatever that drone is that they had. So it's showing that not only is it a big deal for just us, it's a big deal across the world. And we're finally getting on board with it. Another one, they had a counter UAS testing and sensing at Yuma, where they designed primary interagency test and training hub for small sUAS class 1 and 2, concentrating on counter sUAS testing while other large systems are handled at White Sands missile range. Let's see, what else do they have?
But you're wishing you were in the Army now to be able to compete in some of these things, huh?
Yeah. This would have been way funner, especially with I was doing the RC stuff at that point. Man, it would have been so much easier to kind of do it back then. I made a career change quickly to go do that. Only problem is I don't know if I want to deal with infantry side of things at times. Like, yeah, it would have been interesting. But I think that's all for now. If we have anything else that covers or changes anything that's coming up, we'll definitely put it up in our next episodes. With that being said, we want to say also thank you for all those who have been subscribing, following, and liking our content. We've been noticing the growth. We're at 80 subscribers now. We're hoping to get to 100 before the end of the month. So that would be amazing if we can get there by the end of March. So if you like our content, please like, subscribe, share it with others and people that you know that would like this content also, and help us to get it out about the information that we're providing. And again, thank you. We'd like to say all those who've been looking and watching us also on our podcast. Thank you for that too, because you guys have been helping us grow. We've been getting a steady group of people who have been watching and coming back forth. So thank you all for people on the podcast and all those who are on the YouTube who's been watching us. And we appreciate the help and growing. With that being said,
Yeah.
back to you, Josh.
Yeah, I appreciate it. Yeah, no, we do. We really appreciate all you guys and the time you take to watch our content. So let's go ahead and start with the basics. Yeah. So somebody buys a ready to fly drone, never opens it. What is a flight controller without all that like engineering jargon?
So flight control is a central computer or the main processor of most sUAS. It's what your sensors connect to. It's reading those sensors, is listening to it, and it basically the autopilot of what the aircraft does. And it continuously tells in each motor what to do. It tells how fast to spin, how the actual stay at altitude that it needs to be at. It tells it the information that it needs to basically do everything it needs. And basically it keeps it in a place where it's keeping it stable and able to do its flight paths as needed. So that's pretty much what a flight controller is. It's basically your computer in the sky.
So it's not just a receiver to monitors. There's an actual brain in the middle making decisions.
Yes, exactly. It's running loops 100 times over and just kind of going back and forth every second to thousands of times a second, sensing and deciding and acting on what it needs to do. And it senses motion, attitude, and all this comes from IMU and the barometer, which decides how to correct or move, then acts by sending signals to the ESCs to speed up or slow down the motors. The flight controller is basically working as a synchronized, harmonious system, basically to fly in the air. So in actuality, you would really think that it would be simple, but it's actually a lot of things going on in there to make it work.
Okay, so give me the moment where that loop saves somebody from embarrassment.
Yeah, so imagine a gust of wind. It comes in from like right or left or wherever. The gyros feels that as roll, and then the flight controller instantly decides and adds thrust on the right to reduce the amount of force that's needing put into on the left. It corrects it before the brain can even have time to react. So if you were in the air and you had, say, aircraft staying, wind's hitting it, as that wind's hitting and it's starting to do this, the motion of it moving it, the aircraft is already knowing push down on this side to right itself and or turn to where it can go back into the wind. So it does what's necessary without you having to actually do it yourself. Because if it was wind pushing you and you didn't have the reaction of the flight controller on it and you're having to do it yourself, you're now reacting to every last moment, which can be overwhelming and inundating as an
So
operator.
it kind of acts as its own like counterbalance to be able to
Correct.
keep itself. Okay, I got what you're saying. So every time someone says these things just fly themselves, what they really mean is there's a tiny computer fighting physics 1,000 times per second. So that's not magic, that's control theory. So
Yeah.
let's say you open it up, right? Tiny PCB. Looks like a circuit board from a microwave. What are we actually looking at?
So what you're looking at is the main processor. You know, flight controllers use a software or a firmware called STM32 or a microcontroller called STM32 microcontroller. You have different types of flight controller or microcontrollers. You got F4s, F7s. Sometimes in some boards now, especially with the newer ones, you got the H7, which is a higher end board. F4 is already solid. It's a pretty standardized processor. It's been in the industry for a long time now. The F7's also been around a little bit. It's just kind of been more of the replacement for the F4. A7 has got more processing power and it can do a lot more in regards to adding more peripherals as you go. So it's just thinking of like going from the old 186 computer to a Pentium processor, you know, to the i7, which is what you would see for the H7. So if you go from a Pentium 1, which is your F4, to a quad core, which would be like your F7, to going to a i7, i9 processor, which would be your H7. That's the transition that you would see in regards to the performance and how those performance loop rates are considered to be better in that aspect.
Okay, so let's be real. Let's be honest with our listeners here. If I'm trying to pick between an F4 and an F7, what are the actual changes that are going to, what's the benefits?
So what you're doing is in practice, you're, adding more headroom. So basically, the faster that processor can respond, the better your opportunity for that aircraft to do what you're expecting to. On top of, it can handle more. So you can run a higher gyro pid loop or frequencies. You can have better and more advanced filters. You can log more data. You can still have your UARTs, but you'll have more of them left to do the things that you want. So say you need the higher processing power to do, say, a high level, camera rig or mapping aircraft. So if you're just going out just to fly and you're not doing anything really major and you don't need a whole lot of sensors on it, the F4 would probably meet what you need. If you need something that's like in between, but you don't want to spend a whole lot of money, the F7 would probably meet a lot of your things you need. And you don't have to worry about it being over inundated with all the sensors, because it can still kind of handle it, but you can't add a lot to it. Whereas the
Okay.
A7, literally, it can handle the flight controller. It can handle all the processing of the information that's coming in, and it'll allow it to work better. Now, I'm not going to say it's going to be probably 100% as what you really all want, but it would be way better because it has typically more processing speed. It's going to have a higher memory or buffer state to where you can actually input more into it, so it can be able to handle all those sensors in a better way.
Okay. So when somebody buys the cheapest board possible, and then 6 months later, why can't I add GPS, digital video, and telemetry? That's because they ran out of room on their brain?
Yeah, it's one, they have to have that capability in the flight controller. So you have to look at what you're looking for when you buy it. You need to make sure that, perfect example, like, well, I guess that wouldn't be. I was gonna say the bidirectional D shot but that would be your ESC. So what will be a good option in regards to, say you get a flight controller that doesn't have software capability. Say it's only meant for betaflight. That means that you're not going to have all the autonomous modes that you may want to do with, like, adding a waypoint mission. Whereas if that flight controller is capable of adding inav or ardupilot, then you're adding the capability of being not only just kind of semi or just doing a FPV drone that's just for just racing or flying. You actually have some professional uses that you can add to it, and actually a little bit more clarity that you wouldn't have on the others. So looking at your specs, looking at what it's saying it needs, is a very important part of what you do when you buy your flight controllers.
What you're saying is, like, you just took a $40 decision, and instead of buying something that you needed to be able to add on to later, you've now turned that into a complete rebuild because you didn't have the capabilities that you thought you did.
Correct. So
Okay.
you just got to make sure that you're looking at all the things that go into it to make it fit what you need for your regards to your build. That's like we always say, it's important that you look at what you're building and you build to your design intent, and not just building something just to be building it.
Okay. So IMU discussion. All right. So sensors, IMU, what are we talking about with that?
IMU is your initial measurement unit, which is what IMU stands for. It bundles a gyro, the accelerometer, and sometimes magnetometer together. The gyro measures how fast the aircraft is rotating around each axis, and the accelerometer measures the linear acceleration, and the flight controller fuses that data to figure out the drone's attitude and motion. That's pretty much what the IMU is doing.
Okay. So if the IMU is junk or garbage, what do you actually see as a pilot?
You'll see it with being basically twitchy, have weird oscillations, or it won't have the ability to keep up with what you're giving as inputs. Or, if it's a quadcopter, it might slowly drift or lean when it shouldn't be. It should be level. So if you have it in hover, instead of it sitting level and hovering, it could be shifting. So if the mic is the ground and you can see it shifting, what you want, which goes into PIDs also, you want it to sit as level and as constant as ever. If it's going like this, that means you're either PIDs are out of tune, or that IMU is just not doing well one way or the other. But 9 times out of 10, it's normally you're programming your PID. So
sometimes it's not you as the operator. Sometimes it's the physics, or it's just cheap silicone and poorly made.
correct.
Okay. So the hardware is just half of what the build is the actual personality. Let's do 3 big names, break them down.
So in regards to firmware, you have 3 of the big ones that we use. Betaflight has been around for a good little minute now. Inav, which came around, I want to say about 5 years, maybe 3 or 4 years ago. And then you got ardupilot, which has been around for a while also. The main difference between these 3 different programs is that Betaflight is your FPV flight controller software. Typically, you can put all your stuff in there. make your aircraft fly as well as you need in regards to just doing FPV flights, more of a hobbyist type program. Inav is the in between Betaflight and ardupilot. Now you can add your GPSs and you can do your mission planning to a point and just put in waypoint missions and different things. Whereas is literally like more professional side of open source professional side aircraft software where inav can do your basics of putting a GPS on other sensors and making it work something similar to like what an FPV build would be. Pilot's like Betaflight on steroids. So it can literally tune out just about every frequency or anything that you need. You can add in all your different systems that you want to put on it. You can pretty much adjust every parameter you need to in your aircraft that you're building. You can make any type of aircraft because not only would you be able to do a quad, it changes it to where you can have an octo quad. If you want to have an H-stat quad, you can have that. You can do several different things, but that's the main difference between those softwares. And the Betaflight more so, like I said, kind of clarify it, dominates on FPV freestyling. inav covers more of your GPS and assisted FPV and cruiser aircraft. And then ardupilot is basically a lot of the commercial research and mixed vehicle platform software. So a professional basic software that you can use to do whatever you need.
All right. So let's put this in no rambling, just 10-second decision tree, and give them the simple answer for each one of those again so that they can understand what they're actually getting. Go.
So Betaflight, if you just want to just go fly and you want to get something up and running and you want to do just FPV flights, that's your thing. If you want to go a little bit further and have something where you don't have only a simple flight mode of just, hover or acro, you can go into inav. Inav will give you your GPS capability of basically doing the simple stuff, but having capability of tracking where your aircraft is. From that, the next step up will be ardupilot, where if you want to get professional and you want more in the weeds, detailed information to fly your aircraft and do everything you want in building like a prototype build aircraft, ardupilot then would be the software that you want to use to build your aircraft.
All right. So if you're doing mapping pipelines with Betaflight, you're wrong?
Yeah, it wouldn't do it. I mean, you're not going to get all the functionality you want. Could you possibly do it? Yeah, I bet you there's somebody out there. I use Betaflight all the time to do this. Well, that's not what it was made for. Betaflight is not made for that type of need for a drone.
So you're in engineering speak, you're saying, stop it. This is not what you're using the wrong tool.
Correct. I mean, you can use it, but let's put it like this. Will you be able to give me a mission plan that you use to do your work with? What are you using as software to kind of like give any data that shows me that, hey, I did my flights here and this is where I was doing it from and this is what my flight was and this is what my data, because I can output a log using mission planner that shows what I did and what the aircraft was at, how well it flew. Whereas Betaflight, you can get logs, but it's more on just the tunes. You're not getting like actual flight mission data.
Okay. So let's turn this into a financial question, money talk here. If I'm building a fleet, not just one hobby quad, what's the first question I should be asking myself?
So price, what are you wanting to do? Are you just trying to fly? If you're just trying to fly, the flight controller you want is something that is basically built around just FPV. You're looking for a FPV flight controller like the Speedy Bees were before they were, discontinued, something similar to that. If you're looking for something that's a little bit more than just a regular FPV flight controller, you can step it up to Hobby Wings. They have some decent flight controllers also that you can reuse to not only do just FPV stuff, but you can use them to kind of do your putting around and mission planning and not spend an arm and a leg on it also. So it's like you're in between. And then you have, if you're really getting into, and this is all a anecdotal for where we are, because you have all sorts of different flight controllers, by the way. But on the last one, if you're looking to do something that's more professional and you're looking to get it into a better aircraft system that is more prototyped or specific to it, you want to look into Pixhawks. A Pixhawk based aircraft has a more robust system of redundancy in your sensors in it. They also have the capability of adding in more peripherals as you need. And they also have already industrial grade or enterprise-based systems like RTK add on, LiDARs you can add to it. They're built to be a professional flight controller, but they also come with a cost. The hobby wing, you're looking at about $100, whereas or a little over $100 for something that's got more of a capability of going to add in ardupilot. The Speedy Bees, they can go up to 100, but they're typically about between 40 to 89, $80 to just get a regular flight controller. That's all in one. That's up with everything that you need. ESCs and flight controllers, I should say. But then, so you have an option where even with the small one, so like kind of what I built for this one as an example, that flight controller is all in one, but it only costs $100, and I can do pretty much everything I need to, adding into mission planner, adding it, whatever other peripherals I may need, but it may have its own limits. We'll have to see and learn. But stuff like that.
Okay, yeah. So for guys running 3, 5, 10 aircraft, what's the biggest mistake people make?
I think the biggest one is that if you don't know and you're building, like most people, I think after they get to that first aircraft built, they'll start realizing quickly what they need from there. If you built 5 aircraft and you didn't actually fly it first, then you may want to question like what you're doing. So unless you know, it should be just everybody start with one, figure out how it flies and how it works. From that point, you want to go into positions where now you know what you need, you know what you want to do, and your flight controller helps you to identify all the other add-ons that you want to do from the future. So that help you out understanding the basics on it.
All right, so basically, not standardizing your stacks is going to cause you with 3 different firmwares, 4 wiring harnesses, 2 different mounting patterns, and just one giant headache. So would you say standardize or suffer the consequences?
Yeah, eventually figure out what you want from the first build, knowing how it works and what you like. And then from there, you can pretty much build your next continuous aircraft after that. And you'll learn. Trust me.
Okay.
As you do it, as you know, you'll learn from it as you go. Because after a while, you're gonna be like, oh, I don't want this on here now, and this ain't helping me, or this took too much work to actually do more for it. So you'll end up learning over time. But if you don't know that, you're getting a heads up now on what you will learn as soon as you get to building it.
All right. So let's go over common mistakes. What's the first biggest top mistake people make?
I think most people come into it thinking that, oh, this will be simple. I can get something built just because I've looked at a video or understood for someone, not realizing that you'll have to go in, and if you haven't done this before, you'll have to learn how to connect your ESCs and know what you need for those components that connects to that flight controller and what you're looking at as you're setting it up. Because if you don't understand that, say you have an ESC that's connected to the flight controller that you're reading on that says bidirectional, but in actuality it isn't bidirectional, you'll try to set it up for something that doesn't actually work with what you're doing. So understanding that you will run into your build, unless it's already a pre-built aircraft, unless it's something that you bought from the store that has pre-built settings and parameters, you're going to have to do research ensuring that that flight controller also doesn't get fried in the process of you building it. So in other words, having something like a smoke stopper, we call the magic smoke, you don't want to get out on your battery. In this case, let me show as an example. On here, you can actually add this to the battery, gives you a light. Once you add that to the battery, now when you go to plug it in, let's see, you plug it in. So after you hit the button, oh wow, it worked. And I didn't burn my battery up or burn my aircraft up, should I say, because as soon as you plug it in, if you had something that was shorted, that will make your aircraft decide that it wants to let out magic smoke. So that means you just fried something. And simple as this too, having something like this helps you do other things for programming that we'll talk about later on. But that's another common mistake. People will build something, plug in power to the flight controller, and then burn up the whole fucking system because they didn't realize they had something that they shorted, not realizing that one pin should have been on another position and you had it 5 volts where somewhere it didn't need 5 volts.
So people think software fixes everything now, but that's not the case.
Correct. You have hardware options and things that you have to go through. Software can help you pick out the main components of or not pick out main components. It'll help you to solve the problems that you have in regards to getting it flying, but it's not going to fix you putting in the wrong component in the wrong place.
Okay. So if your quad is shaking like it just drank 5 Red Bulls, it might not be your PID tune. It could be what else?
So if it's not that, you may want to look at vibration. So like dampening the vibration on your flight controller is the key thing that you want to do. The problem that you run into is that everything on your aircraft has some type of vibration that if you don't tune it, it can cause you to crash because it's trying to get all the jitters out. And if it gets too much in the loop, and it'll just basically fall out of the sky because it's just got too much on it. So you need to ensure that your flight controller is set up in a position where it has some type of dampening, whether it be little gummies where you can put them in between, or you just build a mount that goes to put the flight controller on that actually has a vibration out resistance. Like in a Pixhawk, the Pixhawk cubes came with the flight controller already dampened inside of the cube. You still sometimes need to add a little bit more dampening to help it out, but that's something that you need to do to get rid of that twitchiness. And then after that, go through your filters, your EKF filters and your notch filters, and looking at how to read logs to understand how to reduce it down.
So what you're saying is tuning is not always the fix. Sometimes hardware is the fix.
Correct. You have both.
So this is just one system in the stack. We're covering flight controller, ESCs, the frame, propulsion, power systems, radio link, payloads. By the end of this series, you won't just fly drones, you'll understand them.
Yeah, agreed. Up next, we'll be talking about ESCs and how they talk to the flight controller and what those are and what the current, systems that we use and see, the ratings, the protocols, things like what D-shot means, and what like something by directional D-shot would be different between each other, and how to avoid letting out magic smoke completely, especially in the ESC also. So for the first time, and how to first time arm your aircraft. So
yeah, so drop a comment. Let us know what flight controller and firmware are you flying right now? Is it freestyle? Are you mapping, inspection? And if you're still buying flight controllers based on Reddit threads, we just gave you a better system.
Yep. And if you want more news, you can actively follow us or watch and learn from what we're doing. And we'll actually keep you up to date as best we can on what's going on in the sUAS world. If you like what we have, hit like, subscribe, and share this with other pilots and people that you know who are in this, and other people who are wanting to become sUAS pilots. And I thank you for watching Swarm News, and we'll see you next time in part 2. Have a good one.
Yep, Swarm News, we're out. Thanks, guys. We appreciate y'all.